Hello students. So this is the continuation of our lecture series of hydraulic engineering. So now we will discuss in detail the chapter of hydrology. So today we are going to cover these topics. First we will go through the definition of hydrology as a subject. Then we'll see the very interesting hydrological cycle. After that we will go through the applications of hydrology in engineering problems, particularly in civil engineering. So this is the definition of hydrology. So as I said, hydro is water and logos is to study something. So in hydrology, it is this water, the science of water we are going to explore. So what we are going to deal with the occurrence, circulation and distribution of water of the earth and earth's atmosphere. So it is very interesting that there are two components which we are going to learn. First, the water of earth, like water of earth means the water on surface or beneath the earth surface, and the water in the atmosphere in the form of vapor or clouds. So both all the water which is there on the earth and its surface and present in its atmosphere we are going to study about. So as a branch of earth science, it is concerned with the water in streams and lakes, rain and snowfall, snow and ice, where on land and water occurring below the sorry below the earth's surface in the pores of soil and rocks. So in the earth surface where this water will be stored, so it will be stored in soil pores and rock pores. In rocks it is very negligible, but still we will study the water in the soil and rock. So in general sense hydrology is a very broad subject. So to study the hydrology as a subject we need to know a lot about other sciences also, such as geology, statics, chemistry, meteorology, physics and fluid mechanics. So statics particularly and fluid mechanics, as water is a fluid. So the knowledge of statics, because there are huge amount of data we are going to deal with in while studying the hydrological data. So statics, mathematics, these are like must. So hydrology is basically an applied science because it is not a pure science, because lots of various other branches of science are we are going to apply it to explore the concepts of hydrology. So in general sense what we are going to deal with in hydrology, the estimation of water resource, how much water we are having, the various processes like precipitation, runoff, evapotranspiration and their interaction, how these various processes are going to interact. And this the term evapotranspiration is a combination of two words, evaporation plus transpiration. So this is a combined evaporation from earth's surface and from plants through their leaves. And the third is the study of problems. So what are the hydrological problems? Floods and drought. So these broadly we are going to deal. Next is hydrologic cycle. So this is very interesting cycle. You might have learned this in your in senior secondary or secondary schools. The there it was known as the water cycle. So this cycle is basically the motion. Water can have three states: solid, liquid and gas. Solid is ice, liquid is water, and the gaseous form is water vapor. So how these three forms are interchangeably coming in this cycle, that is that is our main concern. So so like, let's say we are starting from C. So water is going to evaporate, and then by the process of condensation, it will going to it will cool down, and when it is cooling down, the density will increase, and the water will come back to the earth surface. So this diagram, you can go to this site and you can just look at it. So a convenient, so this is a cycle actually. So cycle is no end and no start. So but to study this cycle, we have to start from somewhere. So a convenient starting point is oceans. So this is a question for you to search. Why particularly ocean only? Why not like any stream or surface flow? We are taking as our starting point. So the main source is solar energy. For this cycle, the driving force is solar energy. So sorry. So the water vapor moves upward and forms cloud, while much of the cloud condense and fall back to the ocean as rain. A part of cloud is driven to land areas by wind. So while raining, if wind is there, what will happen? The wind will get transported towards the land, and the rain will occur on ocean as well as wind. So there are condensed precipitates condensed there the condensed and precipitate onto the land mass as rain, snow, hail, and sleet, etc. So these are the form of precipitation. A part of precipitation may evaporate back to the atmosphere even while falling. So while raining is there, due to heat energy provided by sun, a part of this water will go back to the atmosphere itself. So it will not going to come to the earth surface, and another part may be intercepted by vegetation, structures, and other such modification, from which it may either be evaporated back to atmosphere or moved down to the ground surface. So due to these obstructions, so the what I'm trying to say is, like, if, like, let's say 1 liter water is getting evaporated into the atmosphere, so it is not like whole 1 liter is going to come back. Part of it will, like, say 200 ml will be evaporated while raining only. So, and some will get obstructed by vegetation, the structures, and various other obstructions. So finally it will be hardly 200-300 ml going back to oceans or the streams. So that I was meant to say. So vegetation send a portion of water from under surface back to the atmosphere through the process of transpiration. So as I said, the loss of water through the leaves is termed as transpiration, and combined evaporation and transpiration will be studied under a single topic, which is evapotranspiration. This is a loss due to evaporation and the evaporation through plant leaves. The precipitation reaching the ground surface after meeting the needs of infiltration and evaporation moves down the natural slope. So due to gravity, the water will move down and finally it will reach to ocean. The groundwater may come to the surface through springs and other outlets after spending a considerably long time than the surface flow. So what it is saying, the groundwater and surface flow. So there are two, like, after water is coming to the earth surface, either it will move down in as a groundwater flow, or it will flow on the surface. So groundwater obviously will take much larger time. The portion of the precipitation which by a variety of paths above and below the surface of earth reaches the stream channel is runoff. So whatever water is running either on the surface or below the surface of the earth is termed as runoff. This water is running. Once it enters the runoff, once the runoff enters the stream channel, this will become a stream flow. The sequence of event are as above is a simplistic picture of a very complex cycle. So this cycle seems like very like simple, that evaporation, then condensation, then precipitation, then surface flow, then groundwater, then it is coming back to ocean. So this is not going like in actually practically the cycle is very complex. So it is seen that the hydrologic cycle is a very vast and complicated cycle in which there are a large number of paths of varying time scale. So paths are also different and the time scale is also very different. So you can just assume how much complex this cycle is in actual. Further, it is a continuous recirculating cycle in the sense that there is neither a beginning nor an end or a pause. So this cycle is continuous. Continuous means there is no pause. All the processes are happening day by day, like every single second this processes are going on. And recirculating also, the water is going, same water is going to in the atmosphere, same water is coming back as a precipitation. So this is recirculating and continuous. And as it is a cycle, there is nor an end nor a pause, no starting point, no ending point of this cycle. So each path of the hydrologic cycle involves one or more of the following aspects. So the various processes which we have seen may have either one or two or all three processes, like transportation of water. So water will be transported, water will be stored temporarily or change of state, like in evaporation from liquid to vapor. So this is change of state. Temporary storage, like for in streams it is getting stored for temporarily. If energy by the sun is more, so it will get evaporated. Transportation, like water is like in this maximum portion, water will be transported only, like from ocean to atmosphere to surface to again atmosphere. So this is the transportation of water. So it is important to note that the total water resources of the earth are constant and the sun is the source. So the sole energy is coming from the sun. Sun is the driving force for this cycle. The hydrological cycle has important influences in a variety of fields including agriculture, forestry, geography, economics, sociology and political science. It is science actually, sorry for the spelling mistake. So hydrology, this cycle is like, as I said, this is very complex and it is very vast. So it is going to impact a very huge, like this is the area of interest of various other sciences also, like geography. We are going to study water distribution and so on. So engineering application of the knowledge of the hydrologic cycle and hence of the subject of hydrology are found in the design and operation and operation of projects dealing with water supply, irrigation, drainage, water power, flood control, coastal works, salinity control and recreational uses of water. So if we are going to make a dam, a reservoir for this dam, so in this, these are the various applications where we are going to apply the knowledge of hydrology. So what are the application? So hydrology find its greatest application in the design and operation of water resources. We will take the help of hydrology to design and then how it is the structure is going to operate. So both comes under the hydrological application. So in all these projects, hydrological investigations for the proper assessment of what we are going to assess actually. So first the capacity, the magnitude of flood flow, the minimum flow, and the interaction of the flood wave and hydraulic structure. So these are the points which we are going to deal with. The hydrological study of a project should necessarily precede structural and other detailed design study. So before designing the structural part, we have to do the study of this we have to perform the hydrological study, else we will not be the structure is going to fail only. So what is this hydrological study? It involves the collection of relevant data and analysis of the data by applying the principles and theories of hydrology to seek solution to practical problems. So if we are having some problem, we will take the data, we will analyze hydrologically, and then we are going to design the other like structural part we are going to design after doing the hydrological study. So many important projects in the past have failed due to improper. If the assessment is not proper, so we will face the failure of structures. So some typical failure of hydrologic structure are overstopping and consequent failure of earthen dam. Agar if the water is stopped for a longer period, in particularly the earthen dam, it is going to fail. Failure of bridge and culvert due to excess flood flow, inability of larger reservoir to filled up with water due to overestimation of the stream flow. So these type of failure are like, if it is going like a dam is going to fail, so it will be affecting, so like very the water the human life is going to affect very bad. So it is like again homework for you to search for 5 major failure of the world as well as the India, which you can categorize as a hydrologic failure. So this is all for this lecture. Now I am going to leave you with this beautiful video in which this is present on the NASA's website. So okay, thank you and enjoy.